is we can knock out more genes and get something that would barely divide, but that's not useful as an experimental tool. It's not useful to understand components, etc. So it's rapid cell division has to have a lot of extremely fastidious working mechanisms to do. And so that was even a bigger challenge than probably the smaller genome. Mycoplasma genitalium, what is 50 more genes, but divides at what?
15 times faster.
No, I think it's about 5 times actually.
5 times slower for genitalium.
Because it's about 3 hours for this, for SYN3, and about 15 for...
Oh, it's 5 times faster than genitalium.
Yeah.
Yeah. What, I think something we learned is that that the whole idea of minimal cell is a little more complicated than we thought. So naively we thought genes are essential or they're not essential. And as Ham said, there are genes you need to have a reasonable growth rate. And so there's a kind of a trade-off between the size of the genome and growth rate. And we want to have something we can do experiments with. Yeah. And it really is in a way more important to have something that's simpler than anything that exists in nature, and a workable experimental organism. That's more important than it be minimal, because we want, down the road we want to have a cell where we understand what all the genes do, which we don't yet, but we're closer to that than any other cell.